Number 9, integral from 0 to infinity, dx over x cubed plus square root x. This one, you have to be careful. You have to be able to spot that this is a double improper integral. Well, I call it double improper integral. Why is it double improper? Well, because, first of all, it's clear that one of the limit's infinite, so that makes it improper in itself, okay? But this limit of 0 actually makes it improper as well, because when we plug in x as 0, we'll be dividing by 0. So we got to set up the limit definition carefully. And we got to break this integral up carefully, okay? So I just broke it up from 0 to 1. You can break up to any finite number technically, but kind of keep it simple. So integral from 0 to 1, and then 1 to infinity, okay? Again, this is improper, so we write it as limit as t approaches 0 from the right, integral from t to 1 of the integrand, and this one, limit as t approaches infinity, integral from 1 to t of the integrand, okay? We got to check one at a time now. Both of them need to converge in order for our original guy to converge. If even one of them diverges, the whole thing diverges. Okay? So let's check one at a time. Sometimes we get lucky in that we check one of the two and it diverges, we don't have to check the other one. But if one of them converges, we have to check the other one as well. Okay, for this one, how can we conclude the convergence or divergence of this? Well, we can do a comparison test, okay? 1 over x cubed plus square root of x is less than or equal to 1 over square root x on this interval. Okay. You can just imagine that we're adding something, even though it's really small, we're adding something to the bottom of the fraction over here. So we're going to be dividing by something bigger, so it's going to be smaller, okay? We know that this integral from 0 to 1 of this function, dx over square root x, converges. I even showed the work. Therefore, since our thing is even smaller, it will converge as well. Okay, so we did half the battle. We checked that this guy converges. Now we gotta check this guy converges. Okay, and it's quite simple as well. For this guy, we do another comparison test. 1 over x cubed plus square root of x is less than 1 over x cubed for x squared equal to 1. Again, we're adding something to the denominator here. Okay, so we're going to be dividing by something bigger, which means the final value is smaller. Okay, and we know the integral from 1 to infinity dx of x cubed converges. Since our thing's even smaller, it must converge as well. We determined the two pieces converge, so our integral converges as a result. You got to be careful for this one once again, because it was a double improper integral. You have to spot that. I feel like for most instructors and graders, they will not give you credit if you just find out that this part converges. This is probably the part, this is probably the part that most people will be able to spot, but people who are rushing through the test that don't realize that this 0 makes it improper as well will miss out on half the points probably. Okay, so you just got to be careful to be able to spot the double improper integral for this problem.